Okay, so here's the screencast for worksheet 16. Here are the answers. Please mark your answers yourself before I go through the answers. Okay, question 1, answer is C. Okay. Which of the following is an example of addition polymer? So we know that addition polymer must be an alkenes. Okay, they must use alkenes as monomers. If you look at these first two, these are examples for condensation. We also know that protein is condensation. Hence, the answer will be polypropylene. Question 2. Which one of the following formula represents a compound likely to undergo addition polymerization? Again, addition polymerization means I need an alkene, CC double bond. So just seeing which one has CC double bond, you'll see that the answer is D. Question 3. The diagram shows the structure of a monomer. Okay, you see that it's a CC double bond. Here there's a chloride, here there's a chlorine, here is a fluorine. Which polymer can be made from this monomer? So remember, to convert this to a polymer, all you have to do is, instead of CC double bond, write it as single bonds, join out the lines, and put an N here. Okay, so you just see which of the following gives you this polymer, where one carbon there's a chlorine, the other carbon has a fluorine, and it alternates. Note that A, there's chlorine on both sides, so this is wrong. Here, chlorine, fluorine, chlorine, fluorine, with hydrogens here, so B is the correct answer. C, note that the chlorine and the fluorine are joined to the same carbon, which is not the case here. Okay, and D, here there's chlorine and fluorine on both sides, so D is also not the correct answer. Question 4. Which diagram represents a polymer formed by addition polymerization? Again, this shows that it is by alkenes. Okay, so you know that when it's by alkenes, note that the chain form is a carbon chain. Okay, so if you look at the options of A, B, C, D, only B has this carbon chain present. The rest are actually made from condensation. How can I tell? For example, A, do you see this C double bond O group? This makes me know that this is a ester. This is ester linkage. Over here, I have this C double bond O to a N. This is a amide linkage. Then you may not know what is this, but it's not addition polymerization. Okay, for this, it's another type of reaction that you have not seen before. It's a polyether in this case. Structure of a monomer is shown. Which formula shows two repeating units of the polymer made from this monomer? Okay, again, the CC double bond is here. We have chlorine and two fluorines this time. So how it should look like as a polymer with two repeating units is H, Cl, F, F, then you extend it, repeat one more time, H, Cl, F, F. Okay, then just look for the one that matches this. The answer will be D. Is it correct? Yes. Okay, question 6. A section of a polymer chain is given below. The monomer for this polymer would be... Now, just because over here, you see that there's this benzene ring, they are on opposite side. Does it mean that they are not the same compound? Okay, what do I mean? Is the repeating unit this over here, or is the repeating unit this? That's what I'm trying to ask. Okay, so is there a difference between between the purple part and this part that I'm drawing here. Actually, there is no difference. Remember that, same. Remember that CC single bond can rotate. So here, this benzene ring, whether it's drawn on the top or on the bottom, makes no difference. So long as this first carbon is connected to two hydrogen, this second carbon is connected to a hydrogen and a benzene ring, then it is a repeating unit. So you see here that this can all be sectioned out into these repeating units. Okay, so the monomer will be, to convert the polymer to the monomer, what you have to do is, from here, remove the two bonds at the side and join here. So this is the monomer. Answer will be A. Question 7. A polymer has the structure shown below. What is the molecular formula? Molecular formula. Okay, so in this case, what is the polymer? What is the repeating unit? I think if it's drawn in this form, it's a bit hard for you to see. So maybe you want to draw it out. C with two hydrogen, connected to a C, connected to a hydrogen, connected to a CH3. So it goes on and on. Can you recognize that this is actually your polypropene and this is one repeating unit? So what is the monomer? The monomer is propene, which looks like this. Okay, so what is the molecular formula? It will be C3H6. Which polymer has the empirical formula CH? Okay, so C, empirical formula, remember it is the smallest ratio. Here, the repeating unit is C2H4, which means that the empirical formula is CH2. Here, the empirical formula, the formula of the repeating unit is C3H8. No, C4H8, which is again CH2. Here, I have C3H6, so it's CH2. Here, I have C6H8, H8, so it is CH. Answer is D. The diagram below represents the structure of a polyamide. So the clue is polyamide. What is the linkage L? So you need to recognize what is the amide linkage. Remember, amide linkage is C-double-bond-O connected to a nitrogen, and because nitrogen forms 3 bonds, that's why there's this hydrogen as well. Okay, so answer is C. The structure below represents nylon. Okay, what is the repeating unit in this structure? How can we break it down? That this is the amide linkage, this is another amide linkage. Based on this, what are the monomers? Is it that there's one monomer or that there's two monomers? Remember that there are two possibilities. I can have one structure where one side is nitrogen, the amine, the other side is your carboxylic acid. I can have this kind of structure, or I can have diacid, added to amide. Which possibility is this? Okay, you should note that here the nitrogen is connected to the same block. Okay, this nitrogen is connected to this block, nitrogen connected to this block, which means that it's a diamide. It's this one, it's the diamide and diacid form. So what is the repeating unit? It will be the diamide and a diacid. Right. Let me see, question 10. Yeah. Okay, question 11. Okay, again, let's look out for this linkage. The linkage here is this. Okay, so what is this substance? Is it an addition polymer? No, we see that these are ester linkages. Okay, so it is a polyester. Part of a polyester chain is shown below. Which compound, when added to the reactants during polymerization, would stop this chain from becoming too long? Okay, now I think this will be the question that most students will have problem with. What compound, when added to this substance, will stop this chain from becoming too long? Again, you need to recognize what type of reaction is this. Okay, so this is the second form again, where this is monomer 1 and this is monomer 2. Okay, and in fact, your A and B is monomer 1 and monomer 2. Okay, how do we stop this chain from becoming long? Recall that we need to have linkages on both sides, okay, for it to polymerize. So to stop it from becoming long, we have something that has linkage only on one side. So how does this work? So let's say I have this block here. Okay, if I am linked with something that only has a OH on one side, note that after I join them together, then there's nothing else here. No more, nothing else here. So this is where the chain will terminate. Okay, so the answer is D. Why does C not work? Because C can just form a polymer by itself as well. Okay, note that this is in the first type of form where we have an acid on one side and the hydroxyl group on the other side. It can polymerize by itself. Okay, it can also add into this reaction because the acid part can react with the hydroxide part and the hydroxyl part can react with the acid part. 13. Polycarbonates are synthetic polymers. Their structures are shown as below. Which of the following has a type of linkage similar to our polycarbonate? Okay, so you see that the linkage looks like this. Which of these has a similar type of linkage? It will be a polyester. Okay, we call it polyesters, look like this, their linkage. Okay, whereas this slightly different. So they say similar. The most similar one is the polyester law. Question 4. The diagram shows the structure of expanded polyurethane. Again, you identify what's the linkage here. The linkage here will be this part. This polymer. So again, what type of compound is this? We can again break it into this is one monomer, this is another monomer. This polymer is going out of use. Which of these following set are all the atmospheric pollutants when this burns? Okay, this is not even relevant to the polymer. Okay, it's not even relevant to polymerization. You just need to identify what are the atmospheric pollutants formed when this burns. We see that there's carbon, there's oxygen, there's nitrogen and hydrogen. So we have that can't be sulfur. There's no sulfur in this compound. So C is out. and they want it to be a pollutant. So it can't be water, because water is not a pollutant. So answer is A. No more already. Oh, okay, so that's a short assignment. So that's all for the screencast for worksheet 16. Here's the answer again for you to check.